Hi everyone, this is Jake Bordens. Sorry I couldn't make the meetup this month, but there's something I wanted to present, so I recorded this video. For those who don't know me, I've been around the community since 1997. I have various development projects and a couple hardware projects as well. You might remember my presentation in 2020 on the mysteries of the internal serial slot. You can find that on YouTube if you're interested. We're going to continue some of that work today. This is my standard disclaimer. A lot of this is poorly documented and some of it is 20 years old, so if you try any of this at home and you burn down your house, it's not my fault. Proceed at your own risk. This slide's from my presentation in 2020. It talks about what the capabilities are of the internal serial slot. There are 3 serial channels on this port, unfused power pins, the ability to act as a power adapter input, access to various power supplies, an additional GPIO pin, and sound input. And so I used this to develop the Newton Wi-Fi card. And while this was a great card, it had a PPP server on board and an AT command set, so the Newton thought it was dialing up to a 1990s era ISP. Unfortunately, the module was discontinued and also was encumbered by US encryption export law. It's always been in the back of my mind that this was never really widely accessible, and what could we do to make it more accessible? So what if we were to design something new? Well, first, I'd choose a more commodity Wi-Fi module like the Espressif ESP32S3. This is widely available, used on many development boards, is not encumbered by encryption export law. The ESP32S3 has a USB connector, so why not expose that? And if we have a USB connector, why not use USB power delivery to charge and power the Newton? Since the internal port has 3 serial ports, why not hook them up to the ESP32 and see what we can do with them? So we've got a modem port, we've got a keyboard port, and we have the serial channel 0, which is the dock connector, which has an interesting asynchronous mode that I haven't played with yet. And also there's a GPIO pin for various other uses. It can be an input or an output. And ideally it would be something easy to manufacture. So here it is, the Newt ESP32. Let's go over some of the features. So first, that USB port I mentioned, a power delivery sync chip that negotiates 9 volts when connected to a USB power delivery power supply. I put some boot and reset buttons there. They're useful for developers to program. They're hard to access when they're installed in the Newton, so they're really not very useful, but they're a last resort if you need to reprogram the module. Of course, an ESP32S3, a 7.5 volt regulator so that you can take that 9 volts and turn it into 7.5 volts, which is what the Newton expects from a power adapter. A 3.3 volt regulator to power the rest of the circuit. Something called an ideal diode we'll talk about in a minute. A PTC fuse just to be safe because these are unfused power pins. Some circuitry to enable and disable the 3.3 volt power supply. Some tri-state buffers. These interface the Newton's signals to the ESP32 and are the thing that obeys those selector pins I mentioned earlier. Some XOR logic to invert flow control signals. I have a history of getting flow control backwards, so I put some hardware in to kind of prepare for that. Unfortunately, I think this caused some additional hardware bugs to creep into this design, which are going to necessitate future versions probably. And there are also some LEDs on the board. Now, in an ideal situation, this is installed in your Newton and you never see them, but I wanted some external visibility to the performance of the circuit when I was testing it for the first time. The first one is a V-bus light that lights up when there's power coming from the USB-C port. An LED to show that the 3.3 volt power supply is running. An LED to show that there's power coming from the Newton's battery. And an LED to show that the 7.5 voltage circuit is running. And an LED connected to GPIO so that the ESP32 can blink. So let's talk a little bit more about what it means to be a power adapter. If you read the docs, there's this line about using a 10 milliamp current limited voltage at the same level as the unfused power pins to tell the Newton that there is a power adapter connected. And again, I recommended that you want to power your own design using these unfused power pins so that you don't overload the power supplies of the Newton, and use a polyfuse, which we talked about on the previous slide. Also, this PS adapter in signal is important, but you can't just connect a resistor to it and be done, because the Newton will always think there's a power supply if you do that. So just to talk about it a little bit more, these are the power pins on the internal serial slot. You've got 3.3 volts from the Newton, you've got 5 volts from the Newton, you've got that unfused battery voltage, and you've got 12 volts. All of the regulated power supplies here are shared, so you don't want to consume too much of them because you might not have enough power budget for your design. And so I use the unfused battery voltage for most of the powering of the circuit. So what happens if you connect up a 7.5 volt supply? Well, this is bad because right now the Newton doesn't know that there's a power adapter connected, so this 7.5 volts is conflicting with the internal battery, potentially an external power supply. And if you look at the documentation, you'll see that you need to put this resistor in place. And this looks like it will work, and in fact, if you did this, you would even see in the extras drawer, the battery indicator would say that you're now running on a power adapter, which seems like it's what you want. But when you take the power adapter away, you still have voltage or current going in this direction from the battery pins into power adapter input, and the Newton will continue to think that there's a power adapter connected. So what can you do? Well, you could put a diode here, and diode acts as a one-way valve that only allows the current to flow in one direction, and so in this case it would work. If you hook up that power supply again, the Newton would indicate that there's a power adapter connected, and if you would disconnect the power adapter, it would then go back to running on battery. But there's one problem with this design. The problem is you have a 0.7 volt drop across the diode. This means at those battery pins, you're no longer providing 7.5 volts, but you're providing something more along the lines of 6.8 volts. I don't understand this operating region chart very well, but I do know that 6.8 volts doesn't have a very large operating region. So I wanted to get closer to 7.5 volts. And to do that, I use something called an ideal diode, which isn't really a diode at all, but a small circuit that acts like a diode, allows current to only flow in one direction, but has a very small voltage drop, meaning that we can push this up to closer to 7.5 volts. And from here you can power the rest of the circuit on battery or power adapter. So what does this board do right now? Well, I've tested USB serial pass-through to the dock port and to the modem port, and put a little logic in there to do baud rate switching. So I have actually been able to install packages over USB using the standard dock app and NU10. The modem port and keyboard port work for serial debug logging. I can get it to blink the LED. And I'm using the tiny UF2 bootloader. It's a bootloader that allows you to install new software. A little bit of logic in the firmware to trigger the bootloader when I need to install new software. And this is important, that if you write new software, new firmware, you need to make sure that you can trigger the bootloader, because if you can't, then you need to take the board out of the Newton, power it, use those reset and boot buttons that I mentioned earlier to get it into the bootloader mode to load your new firmware. And so having a software bootloader really helps speed development. So let's talk about what's been tested and what hasn't. I've checked serial channels 0, 2, and 3, and they all seem to work. The LED blinks, which I use as a sign of life. USB power delivery seems to work, but I'm hesitant to say that it's safe to use. I think a lot more testing would be necessary. And I personally will never say any of this is suitable for anyone else's use. Use at your own risk, after all. Flow control does seem to work on channel 0 and 3. I can get data to go both directions with flow control enabled. Whether or not it's actually doing flow control, I'm not exactly sure. I have not yet gotten serial channel 2 to work as a keyboard, but it does work as just a normal serial port. I haven't yet played with the synchronous mode of serial channel 0. The synchronous mode, if we can get it to work, in theory, would allow us to go up to 2 megabits, which would be pretty fast compared to regular serial data rates, at least. Some things that didn't work. I should have read my own notes. I manufactured the PCB a little too thick. I used 0.8 instead of 0.6 millimeter PCB manufacture. So it's a little tight when you go to close the lid. Also, USB power delivery and data does not work at the same time. I had assumed that a MacBook Pro could put out USB power delivery and data at the same time, but when you connect up the device to your Mac only puts out 5 volts. That's not enough to energize the 7.5 volt power supply, and so it's not enough to run the board. There are some ways around that, but if you're powering it from inside the Newton, you can get around and still program it. Also, I mentioned before that XOR flow control logic. I found that for reasons I'm not fully understanding, I had set all of that like I/O logic to be powered by the Newton, and the idea was to keep the Newton's power supply and voltages and signals separate from the 3.3 volts that powers the board, and I kind of have like a separation of powers, or at least the power rails. But unfortunately, what happens is that 3.3 volt power supply from the Newton back powers the 3.3 power rail through this logic circuit, causing like weird half-powered states to happen. And so, I have to kind of bodge the board a little bit by cutting a trace and doing some things. But next version, I wouldn't. I would just use a single 3.3 power supply, and I think that'd be sufficient. So where do we go from here? And I'd admonish that, like, as much as I enjoy this, I may never get to any of this, maybe 5 years from now. But I'm trying to enlist some help of people like Matthias and other people to help with some of the development. We could implement the Wi-Fi functionality. Right now, it's just I'm using the chip as if it were a serial bridge. But there is Wi-Fi functionality. I don't know if we can implement a PPPD server like the old YReach module that I used, or Matthias was even saying a custom driver for Newton Internet Enabler. The board also supports, or more accurately, the ESP32 supports Bluetooth Low Energy. So in theory, you could connect to like a wireless keyboard if we can figure out the keyboard stuff. But also kind of in the back of my mind is like how the Apple Watch works, where it has kind of a Bluetooth Low Energy sync with your phone. So you can theoretically have like a host app on your phone that synchronizes over BLE. We could look into the synchronously clocked serial channel 0 up to 2 megabits. It's documented, but I don't know if it actually exists in the Newton firmware, but we could try it. So I know the question everyone's asking is, can I get one? And no. Well, maybe eventually, but right now it's involves like hacked hardware, fixing hardware errors. The connectors are a problem. So just so people are aware, like I had 5 of them made. They cost about $170. I've already mentioned that there's some problems that need to be fixed in the next revision. For example, the PCB thickness, fix that 3.3 volt power supply issue. We could also add some other features like an SD card, or hooking up some of the additional I/O pins. There's no reason we couldn't do that. But we still have problems in manufacture, and one of them is our second favorite connector. That connector is actually still available with a 14-week lead time. JLC PCB, which I use to manufacture these boards, will purchase and maintain a private parts collection for your designs. So we could take up a collection by 100 connectors, have JLC PCB order them, hopefully 14 weeks later. They tell me they're in stock, and we can then manufacture boards with the connector. Right now I'm manually soldering the connector, and I'm having mixed success. So let's do a quick demo. I'll show you it in action. I've got a Newt ESP32 here and another one installed in the slot in my Butterfly Newton. The Newton is currently sleeping, and right now there are no LEDs. Actually, there should be a battery LED lit, but I accidentally burned it out on this prototype, so it's not. But normally you would have actually battery voltage right now. But when I turn the Newton on, if you can see kind of the glow of a LED here indicating that the 3.3 volt power supply has been activated. So if I were to now say plug in a USB cord. This cord is going to my my MacBook, and if I say launch PT100 and connect to the modem port, which is serial channel 3, and type the word hello, you'll see here that the serial link is working as expected over USB. Finally, the last demo I'd like to show you is USB power delivery. I'm going to launch the extras drawer, and if I connect up a USB power delivery power supply that can supply 9 volts, you'll notice that this indicator now indicates that the Newton is charging over USB power delivery. The LED that's lit here indicates that the 7.5 power supply is now active. And if I were to eject the battery, it'll just take a minute for it to update its status, but it'll eventually realize that it is no longer charging. It is now running on the power adapter. And that's all I have for you today. If you have any questions, you can find me on Discord. Sorry I couldn't be at the meeting today. Talk to you guys soon.